How do different pressure units cause confusion? Imagine trying to compare two different ways of measuring the same thing and ending up with two completely different numbers. That's what happens with pressure units in thermodynamics. Pressure is all about force applied over an area, but the way we measure that force can vary a lot. The most common unit in science is the Pascal, which is 1 Newton per square meter. But in everyday life and engineering, you might see pounds per square inch, bars, or atmospheres. Each of these units has its own size and scale, so mixing them up can lead to mistakes. For example, 1 atmosphere is about 101,325 pascals, but that same pressure might be shown as 14.7 pounds per square inch or 1.13 bars. If you forget to convert between these units, your calculations could be way off. Another layer of confusion comes from the different types of pressure measurements. Absolute pressure measures how much pressure there is compared to a perfect vacuum. Gauge pressure measures how much pressure is above or below atmospheric pressure. If a gauge reads 0, that actually means it's at atmospheric pressure, not 0 pressure at all. Vacuum pressure is a special case of gauge pressure, indicating pressure below atmospheric level. Not knowing whether a pressure reading is absolute or gauge can cause big mistakes, especially in thermodynamics calculations where total pressure matters. For example, using gauge pressure instead of absolute pressure in gas law equations can give you incorrect results. Devices that measure pressure also add to the confusion. Some use liquid columns like manometers, which measure gauge pressure. Others use electronic sensors that give absolute pressure readings. If you don't know what kind of device was used or what reference point it's based on, you might misinterpret the data. Plus, in real-world applications, different fields prefer different units. Engineers might use pounds per square inch, scientists often prefer pascals, and meteorologists might work with bars or atmospheres. This mix makes it necessary to be very careful with conversions and understanding what each measurement really means. In thermodynamics, it's especially important to use absolute pressure for calculations involving gases. Gas laws and energy equations depend on the total pressure exerted by the system, not just the pressure relative to the atmosphere. If you forget to convert or misunderstand the pressure type, your results could be wrong. To avoid this confusion, always specify the pressure unit and whether it's absolute or gauge. Convert all pressures to a consistent unit before doing calculations. And make sure you understand what the pressure value actually represents in the context of your work. Clear communication about pressure units and types helps keep thermodynamics calculations accurate and straightforward.